There's three different ways to solve this. One is brute force method, where you'll pick a node and then check if it is common between the two linked lists. That is, if you fixate on A1, then you'll check if A1 is present in the other linked list. Similarly, you'll check on A2 if it is present in the other linked list. And then when you come for C1, since it is present in the other linked list too, then it has to be the intersection point. That is brute force method. Second, there is hash table based method, where let's say you have two pointers, A and B. Both of these pointers take one step at a time. That is, A moves and then B moves. Similarly, both proceed until both the pointers become null. So, you have a hash set that stores node addresses and can tell you if you've already visited a node address which is a part of the linked list already or not. First, A makes one move and then checks if this A2 has already present in the hash set, which means it has already been visited by the B pointer or not. And then B moves. This proceeds until A will visit C1 and then B3 will from the pointer B will move from B3 to C1. But C1 is already present in the hash set, which means that this has already been visited by one of the pointer. And since this is the first starting common point between these two, it has to be the intersection point. Now that was hash table method. The third is two pointer method that we've already discussed in the intro video. To compare time complexities, the brute force, we'll have to check if each node is present in the other one, which means for each of the m nodes in one linked list, you'll have to verify it against the n nodes in the other linked list. Hence, the time complexity is m into n. And space complexity is constant because we're not storing anything. Whereas for the hash table, we'll be using two pointers that move simultaneously. That is, they will move from the distance m using one pointer and n with the other linked list with the other pointer. So the time complexity will be m plus n. Whereas since we're using an intermediate hash set to check if we've already visited or not, its space complexity will be m plus n. Now the two pointer method, we'll try to code it as we've discussed in the intro video. Okay, step 1 of implementation. We'll implement the logic first. For that, we'll need two pointers. I'm going to name them A and B. It will move through the A arm and B arm respectively. While A pointer is not equal to B, it can be equal when it has found the intersection point or both of them have reached the end of the linked list. Until they meet, both of them will move one step at a time. B will move to B's next. Now, what if A has reached the end of the list, which means it has crossed C3, it will become null. So, if A is null, then it will be replaced with head of B. That is, it will start all over at B's head. For all other cases, it will move one point. The same conditions apply to B also. If B is null, that is, it has reached the end of the linked list, then B will start again at the head of A. For all other cases, it will move one step. We have to return the point of intersection. At the point of intersection, A will be equal to B. Either both of them can be equal to null or both of them will point to the same node. So you can either return A or B for the answer of this question. Step 2. Edge cases. This code pretty much covers all of the edge cases that we have discussed. Hence, there is no need to modify. Step 3. Debug. I've made some errors like not initializing these values. Now let's test if it works. Spend a little more tears and this will start working. Of course, we haven't closed the class. It was bound to happen. And with that, step 3 is done. Now, time for step 4. Optimize. We can use C++ specific syntax, which is auto. This will automatically derive the type for A and B. So now A will have the same type as head A, which is list node pointer, list node star. Similarly, B's type will be derived from head B. This is one step that we can do. Secondly, as we've already discussed in the previous question before, null is considered as false by the compiler. So to rewrite this statement in a concise format, you could use this and do the same for the second pointer, B2. There is one more optimization that we can do to make the code look much more cleaner. This if else statement's entire purpose is to give a value for A. This can be rewritten using ternary operator, which is thereby eliminating these lines of code. And with that, we've made the code look much more cleaner now. Thank you for watching, and please subscribe and share with your friends so they might benefit too. Thank you guys. Bye.